Hey everyone, so today we'll go over the concept of a basis of a vector space. So if we look at number one, so if we're asked to find the basis for R2 and R3, so these two are actually quite similar. And what we have to understand is that when we're asking for a basis of a vector space, right? So the vector space of R2 is simply the X and Y plane, right? So we have the X and the Y. And the question is asking to find vectors where when we take scalar multiples of this vector. So for example, if we'd have C1, so that's a constant. It's a real number. So C1 times V1 plus C2 times V2, blah blah blah, till the end, we can find any vector. So any vector in R2. So that is our goal. So that's how we're going to find the basis. So for example, this coordinate over here, let's say this is 1, 1, right? So we want to find vectors where we can multiply and or add and get this vector here. So any of these vectors, it should span the whole plane, right? So even the negative numbers. So I'll tell you guys directly the basis and explain, and it's going to be easier to understand. So the basis for R2 is like this. So it's the vectors 1, 0 and 0, 1. And the reason for that is, for example, if we take any vector in R2, right? So we're going to have an X and a Y coordinate. So let's say if we have -10 and 3. So we can see that using our basis vectors, we're able to find this by doing, so if we could rewrite this also as -10, 3 like this. So we can see if this is vector 1 and this is vector 2, we could do -10 times v1 plus 3 times v2, which would give us -10 here and plus 0, 3 like this. And if we add them up together, we can clearly see that we get the answer that we had here. So essentially, the basis, the goal is that it spans the whole space. So we see that if we do a linear combination, so this is important, if we do a linear combination of the vectors we have to be able to find any single, vector or matrix in the space. So this is R2. So this is of second degree. So that is why we have two vectors in our basis. So now let's look at a basis for R3, which is quite similar of the basis for R2. So the basis for R3 would be three vectors since we're in R3, so dimension 3. So the 1, 0, 0, 0, 1, 0, and 0, 0, 1. So you could see kind of a pattern repeating. So we just have 1 in every single row here and zeros for the rest. And as we can see, any vector in R3, so 3 to 0, for example, we are able to find this by doing 3 times vector 1. So this is vector 1, vector 2, vector 3, plus 2 times vector 2, and plus 0 times vector 3. And one thing to note is that the vectors in our basis, right? So in this case, we have three vectors here. These vectors have to be linearly independent. So vectors in a basis have to be linearly independent. So it has to be the smallest grouping possible. Vectors in a basis have to be linearly independent. So now let's take a look for a basis of the 2 by 2 matrices. So if we're looking at to find a basis of the 2 by 2 matrices, so the basis would be, so I'll write it out for you guys and it should be easy to understand. So we would have the set of, so 1, 0, 0, 0. So we could see the same concept of it happening here where we just have a 1 at every single possible position and zeros for the rest. So this would be one of the many bases that we can have for the realm of 2 by 2 matrices. So as we can see, if we write any matrix A, B, C, D, right, we can use these vectors and do a linear combination. So we'd have, V1, V2, V3, and V4. So we could do A times V1 plus B times V2 plus C times V3 plus D times V4. So so using this linear combination, we can find any single matrix that is in the 2 by 2 realm. So that is it for the introduction to how to find the basis of a vector space. So this just introduces you to the concept. And I have made another video recently on linearly independency and linear dependency. So if you guys are not too familiar with that, you guys can go check it out. So I hope you guys learned a bit and see you guys in the next video.